everyone, this is Cynthia Rudin. I'm going to give a really quick introduction to our new review paper on interpretable machine learning. It's called Interpretable Machine Learning, Fundamental Principles and 10 Grand Challenges. Okay, so this is the paper, and like I said, it's got sort of 10 challenge areas that are relevant to interpretable machine learning, and I'm going to go through it and tell you what they are real quick. Okay, so the first one is sparse logical models, and we focus mainly on decision trees. So these are models that use if-then rules to make predictions. And the second challenge area is scoring systems, which are very sparse models with very sparse linear models with integer coefficients. And these have been used in healthcare and criminal justice for 100 years. Not always designed using machine learning, but they have been used for 100 years. Generalized additive models is the third one, and I want to point out that generalized additive models are actually a superset. Like they're sort of more general than scoring systems, and scoring systems are sort of a special case of linear models. So that kind of gives you a sense of how these are related to each other. The fourth one is case-based reasoning, which is kind of like k-nearest neighbors. But k-nearest neighbors is only the tip of the iceberg. Now case-based reasoning methods are used in deep learning, and so you can have interpretable deep learning methods that use case-based reasoning. And they're actually, it's not just k-nearest neighbors. It's like k-nearest parts of prototypes, and so it can get very interesting and elaborate. The fifth one is complete supervised disentanglement of neural networks. For computer vision, mostly we're discussing here. And the idea for this is that you want different types of information to travel through the network through very specific neurons. So you might want to create a neuron that's like a grandmother neuron, or a neuron that's like an airplane neuron, so that all the information about airplane that the network is using to make a prediction goes through that one neuron. And then the sixth one is unsupervised disentanglement. So the difference between supervised disentanglement and unsupervised disentanglement is that for supervised disentanglement, you know what the concepts are. So you know that you want this neuron to be the airplane neuron, and you know what an airplane is, and you can provide data to the network that tells it what an airplane is. Whereas with unsupervised disentanglement, you don't know what the concepts are in advance. There's no notion of an airplane necessarily. And so I have an example on the slide from materials science where you don't really know what the concepts are. It's not something that a human would normally think about. Like, what are the specific patterns in the unit cell of a material that matter for the way it behaves? The seventh one is dimension reduction for data visualization. Dimension reduction has long been used to try to take high dimensional data and project it down to low dimensions to try to keep its structure, so that you can understand what's in the data and helps you build models that are hopefully interpretable and make sense. The eighth one is machine learning models that incorporate physics and other generative or causal constraints. A lot of people wouldn't even think a model is interpretable unless it has the correct causal information in it. And so this eighth challenge deals with how to put that how to put that information into a machine learning model, how to put physics into a machine learning model. And the ninth challenge has to do with characterization of the Rashomon set of good models. Sometimes you don't just want the best model according to your loss function. You might want to look at a whole bunch of models that are good and try to understand what that set looks like, so that you could pick the model that's best for your particular task at hand. And then the 10th one is interpretable reinforcement learning. So you'd like to know here how the agent makes its decisions. You want to know in an interpretable way what's the policy of the agent. All right, well, I hope you enjoyed this review paper, and see you later.